Welcome to the Manned Flight Simulator virtual tour. We'll be exploring the F-18, H-60, and the F-35 simulators, as well as virtual reality. We'll also show you technologies such as Next Generation Threat System, or NGTS, Avionics, and mixed reality, and how they support the simulators. Along the way, we'll hear from NAWCAD's experts and members of the Engineer Scientist Development Program.
I'm Matt Mueller. I am the branch head for Manned Flight Simulators Enterprise Operation Branch. At MFS, we've been supporting the Navy for over 35 years. We have 7 high-fidelity simulators and 2 low-fidelity simulators. The difference being a high-fidelity simulator uses real aircraft hardware, displays, and frame to emulate exactly what a pilot would feel and see when they're in an aircraft. And a low-fidelity simulator is a reconfigurable cockpit that can be used to switch out the displays, the controls, and anything that we need to emulate any of the other aircraft that the Navy flies. There's a difference between flight trainers and engineering simulators. What we have here are engineering simulators, and these can be used to do physics-based models rather than effects-based models for RDT&E. Manned flight simulators can also support flight test mission rehearsals. This trains not only the pilot how to do the test event, but also the test engineers how to interpret the data that they are seeing down at the range. Pilots are able to do risky maneuvers in the simulator before they try and do it in the real aircraft as well, for safety concerns. We also support interoperability testing. This allows us to tie the manned flight simulators in with constructive entities or software models and real aircraft, either flying in the chamber or flying in real life out in the air. Our simulators also support human systems testing. This allows us to switch out pieces of hardware or displays with new ones and allow pilots to test the interfaces here safely in the simulators before flying in the real world. In this video, we will show a few examples of how manned flight simulators support RDT&E.
Hi, I'm Steve Naylor. I'm the Fixed Wing Technical Lead in the Modeling and Simulation branch here at Pax River. In Manned Flight Simulator, we have 2 F-18 simulators and we're building a 3rd, and we can move them into various stations depending on the work that we're doing. Cockpits themselves are filled with aircraft hardware, so a lot of the displays and switches, the control stick and the throttle and everything that's around the pilot is all hardware that used to be or can be placed into an aircraft. That adds a lot of realism to the simulation. It takes away some of the questions of if you get into the simulator and it does something strange, sometimes the question is, well, is the simulator correct or not? There's still that question because it is a model and it is a simulator, but the fact that we have a lot of the aircraft hardware in and around the cockpit removes part of that. And so you can trust some of what you're seeing as being true to what the aircraft would tell you in the air. And that's the whole goal, right? The whole goal is to create a simulation that flies and feels and looks and behaves as much like the aircraft as possible. Some other ways we help the fleet here is occasionally there's a mishap with the aircraft and there are questions sometimes about that mishap, about what caused it and how can we prevent it from happening again. And sometimes we play a part in that. We'll analyze the mishap and we'll work with the investigation team to determine what happened and also try alternate events and try alternate pilot inputs. We call them what ifs. What if this would have happened and what if that would have happened? How would that have changed the outcome? And would it have prevented a mishap or would it made it worse? The simulation can help answer those type of questions. And the Blue Angels recently transitioned to a new aircraft and we're helping them discern what is the difference between the aircraft that they have been flying for probably 20 years and this new aircraft that they're transitioning to. Some of that work is dealing with the safety aspect of it. We're looking at what happens when malfunction occurs at inopportune times and how can they safely recover from that. And the other aspect is just working on the show itself and making sure that the maneuvers themselves still fit into the show and they're still done, in an exciting way that inspires the public. So that work went on over a long period of time, maybe a year and a half or so. And recently we've just had the whole Blue Angel team come up and fly in the simulators. And they got a chance to work out some of the questions that they had about the aircraft and the differences between that and the aircraft that they had been flying.
Next up is the H-60 simulator.
Hello, my name is Kevin Lawson. I work with the H-60 Romeo and Sierra as a flight simulator operator. I joined the military back in about 2010 as a helicopter rescue swimmer, flying in the Romeo. We have two cockpits in one. We have a Romeo / a Sierra, and it's just two different makes of one particular platform of helicopter. And what we do is we just mimic real life operations, real life missions, real life flights, and we have all these different computer systems and applications that we can put a full simulator together to create that simulated environment for the pilots to get their training. So the H-60 Romeo and the Sierra are very similar in their operation side. Their main missions is anti-surface warfare and anti-submarine warfare. And that basically means is when the Romeo is deployed on the Navy ships, they go out and fly in front of the ship to ID any kind of contacts that are out there to maybe find some potential threats for the ship to navigate. And also for ASW, which is anti-submarine warfare, and as to we can find, track, and prosecute a submarine just through sensors that we have on board the Romeo. It's a multi-mission helicopter. That's where MMH comes from, is multi-mission. There's radar, we have cameras, we have electronic support measures that can find other enemy radars through our sensors. To put the simulation together for these aircrafts, we use a bunch of different computer programs, all working simultaneously to put together this environment.
My name is Dale Courtney. I'm a subject matter expert for NAVAIR working on the NGTS program. NGTS provides the modeling simulation solution, live virtual constructive for NAVAIR. When we talk about live, we're talking about actual people that are flying the aircraft. When we talk about virtual, that is the troops that are actually in the simulation devices. And when we talk about constructive, those are entities that are software generated. In this case, will be generated by NGTS. In the training world, it is the software that an instructor uses in order to manipulate the simulation environment. Say if you've got a ship, a submarine, an aircraft, a tank, NGTS can simulate all those type of entities. It also simulates the weapons that those entities use. It also provides mapping data to allow the instructor better geographically locate the different entities in the simulation environment. And in many cases, it can actually simulate weather and other conditions.
Next up is the F-35 simulator.
I'm Robert Parlett. I am the primary sim operator for the F-35 flight test program at Pax River. We primarily specialize in F-35B and C for the Marine Corps and the Navy. I run pilot training sims, I run control room training sims, and I run mission rehearsals along with other development testing. One of our primary jobs here is to evaluate the flying qualities of the F-35B and C. F-35 is a 5th generation aircraft that the simulator is extremely accurate in modeling the flying qualities of it. So we can use the simulator for a lot of rehearsal and a lot of build-up and a lot of practice to make flight tests of the actual airplane as efficient as possible. We do this via control room training, either inside the building, or we can actually link up with the test range that the pilots and the test engineers actually sit with during actual flights. We train pilots, we keep them current on emergency procedures, we train control rooms, keeping them current on emergency procedures, and just general training and cadence on how to talk to the pilot, how to run a flight test, how to interact with different environments that are involved in flight tests. We've spent a lot of time over the years supporting flight tests aboard ships. As the Navy, one of our primary jobs is to be able to take an airplane to a boat, and when we do that, we have to verify that that's a safe environment to go to, and we use the simulator to do a lot of that build-up. During mission rehearsals, we'll have engineers come over and they can evaluate the maneuver quality for what they're actually attempting to go fly during the flight test. We can have up to 8 engineers in the room at a given time, and we can also link up with a lab across the other side of the base where they can have upwards of 40 engineers in the room evaluate the entire quality of the mission that they're planning to do. It's a great tool for making sure that everybody involved, the pilot, the maintenance guys, and the engineers supporting the flight on the ground are all on the exact same page before the airplane ever takes off. Hours in a sim are still grossly cheaper than 1 hour of an actual flight test. So if we can maximize efficiency of flight tests via simulation, that's a win-win for everybody. We don't want to waste time, fuel, and resources trying to figure out how to evaluate the airplane when we can use the simulator to nail down a very, very accurate solution before they even take off. F-35 flight test is one of the most efficient flight test programs in history, and a lot of that's due to simulation.
Next up, we'll explore virtual reality.
Hello, I'm Robert Cavillo. I'm an aerospace engineer for Flight Vehicle Modeling Simulation Branch here at Naval, Pax River. We develop the physics models for the flight simulators. It's a lot of aerospace engineering work to try and model the aircraft's performance as it should. Basically, wind tunnel test data, aircraft design drawings, try to incorporate that into our physics models, and we try to make it as realistic as possible. One of the cool projects that I've been working on lately is virtual reality. Basically taking virtual reality, combining that with our flight simulators, and hopefully we can one day use virtual reality as a replacement for all the projectors that we use here in ManFlight. All of our projectors, all of the display systems, they are very expensive, very fragile, very difficult to move around. But virtual reality is finally getting to the point where it can now almost replicate the same performance as all of our display systems. For the time being right now, we are preparing the virtual reality for the future integration, and we have a lot of crew chiefs and pilots try out the headsets, the virtual reality themselves. They are very impressed with the technology, how much has progressed over the 20 plus years that virtual reality has been promised.
Hi, my name is Anthony Saxon. I work for MFS and I support the Vader virtual reality team. And my job is pretty awesome because I get to play video games all day. I have a background in game design and development, and when I had the opportunity to jump on this team, I took it. Right now I work within the Unity game engine and I'm trying to create a virtual 3D HUD for the F-35 aircraft. This has a lot of opportunity to really change how we use our simulators. Typically right now, when we fly the F-35 sim, pilots have to put on a pretty big headset in order to get the HUD displays that they usually would in the actual aircraft. When I get this to work, the pilots can just put on a VR headset and they'll see the same heads-up display that they would in the actual aircraft when they're flying around.
My name is Dan Logan. I'm a software engineer here at ManFlight Simulator. One of the recent projects that I've been working on is H1 Yankee and Zulu Avionics test facility. One of the major components of that avionics test facility is the weapons cart that we use to do end-to-end hardware-in-the-loop testing for the H1 Zulu of different weapon systems. The weapons cart can load up almost any weapon system that the H1 Zulu is capable of carrying, and we are able to run those weapon systems as if they were on a real aircraft using real mission computers and as much hardware in the loop as possible to get good sense of whether or not software is working as expected and the hardware is working as expected, and to try to catch any integration issues as early as possible. So the weapons cart is capable of carrying currently up to 2 M299 racks, which we use to launch Hellfire missiles, and also an AIM-9 Mike Sidewinder missile.
Next, we're going to hear from some of the members of the Engineer Scientist Development Program about their experiences working at the Manned Flight Simulator.
Hi, my name is Carolyn Branco. I'm a 2017 St. Mary's College of Maryland graduate, and I graduated with a math major and computer science and art minor. I am usually coding or working on projectors within the visual display systems. Specifically, other than projector and visual display work, I work on radio and environmental tones for the pilots to make the simulations as high fidelity as possible. Because I am on the lab development team, I work with all the simulators here at MFS. So unlike some of the other employees that work here that specialize on a specific cockpit, I kind of bridge the gap and I work as a lab development team member to help troubleshoot any issues that arise in any of the cockpits.
My name is Jewel Kuntz and I'm an electrical engineer at MFS. The kind of work that I do here at MFS day to day has changed since I was an intern. When I was an intern, I did a lot more of reviewing older engineers' drawings, just learning the process of getting those approved, how everything was working in the lab with the cockpits and all the different capabilities. And now that I am full-time, my job has more progressed into being an active part of that design process and getting to help make important decisions, help order parts for the cockpits, and just be in the ground of that design work. So it has been a really enjoyable experience for me, and I feel as though I've learned a lot along the way. I have learned how to solder, I have further expanded on just all the skills that I learned in school.
We asked some members from the manned flight simulators for their best advice for someone interested in pursuing a career in engineering.
So some advice that I'd give to younger students or students that hope to become engineers, I would say really try to network and build relationships outside of school. You can also build relationships with the teachers that might have connections to the base. If you're in the area, there are a lot of programs that help you get to know and network with certain government members or contractors.
Get started early to talk to older people that you know in the field of engineering, your upperclassmen, and even any adults in your life that you know who are engineers. I would tell you to ask them a lot of questions about their experience in school, their experience in the workplace, and even any internships that they had. And this would really help you get an understanding of what all it entails to be an engineer and the level of academics you will have to go through to be one.
There's a lot of really interesting opportunities, either with your organization that's already there. Maybe you can start your own project like virtual reality. I was asked to get virtual reality off the ground here for NAVAIR. But maybe you can bring your unique ideas and bring that to the organization and support whatever tasking or goal your organization is trying to accomplish.
I remember when I was a sophomore in college at St. Mary's, there was a program called Engineering with Women for a Day, where you took a day to come on base and learn about the government employees and what it would be like to be an ESDP member. So I would recommend reaching out and really going out of your way to see if there are programs like that that would interest you.
Study, 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 consume all the knowledge that you can, and don't be afraid to ask for help. Usually if engineers, especially introverts, it's hard for us to ask for help. It's hard for us to say that we're struggling with something, but in this field, you work as a team.
I would also say to take advantage of any classes or tests that you might have in high school or even right before college, career tests, personality tests, to just further ensure that you do want to pursue engineering. And I would say to trust in yourself and take that leap to take on this field and this challenge and just enjoy it the whole way.
As we've seen, manned flight simulators is used to teach test and evaluation as a discipline, expand the capabilities of how we can train the fleet, integrate hardware in the loop with new capabilities, integrate simulation into live virtual constructive interoperability tests, and much more.
I'm Ellen Cervetnik, the NAWCAD Strategic Education Office Team Lead. We hope you enjoyed this video. If you'd like to learn more about NAWCAD's Education Outreach Program and activities for students in kindergarten through 12th grade, please email us at nawcadeoo.fct@navy.mil, or you're welcome to visit our website listed on the screen. Thank you.